good afternoon to all. I would like to thank the organizers for giving me this opportunity to talk about the corrosion-based issues what we face for in naval platforms. So as we understand that corrosion is an omnipresent and omnipotent issue, and it poses a lots of challenges across all, whether it is household or different industries, and where you know defense assets are all the most strategic and required for ensuring the security and sovereignty of the country. And then, of course, the naval platforms are the one of the most vulnerable assets, which needs to where the corrosion impact has to be measured, has to be monitored, and has to be checked for at all times to ensure that the naval users who are the Indian Navy, whose main role is not to look into primarily these things, but then in order to ensure that their asset is working for operations, mission mode operations. So I'll briefly touch upon few practical case studies. So yeah. So as we see, I would just like to mention that different critical components which naval assets primarily have. For example, the ships and the submarines. The most important part for structural integrity is the ship hull structures, where the underwater shell plate and as well as the weld joints are quite important. And there are then other sorts of very subsystems and components like propellers, pump impellers, valves, diving cylinders. And on the right you can see pointer is there. So as we understand the importance of corrosion, that the corrosion is basically an economic monster for all the nations, and as per the NACE standard report, the entire loss for the overall global GDP is 3 to 4%, and in cost to India is around INR 38 lakh crore as per official government data. So we understand what is the importance. I mean, there's nothing to highlight the importance, but then numbers definitely make sense to understand quantify the importance. And then of course everything is data, so we need to quantify basically the impact on integrity in terms of data, and that's why these numbers make lots of sense. So coming to the few case studies which are actual happened on various INS ships. So these as a young scientist, when I used to go to the ships, I used to see that there are very simple corrosion issues with basic corrosion problems, which causing so much lots of problems. And so, for example, in this case, the hull through and through hull pitting. I mean, as such, there is no problem with the steel; it's the best. But then, in this case, what has happened is even if the paints are underwater paints are regularly applied and all those things, and then often it happens that in the inner side of the hull, the maintenance or the corrosion anti-corrosive paints are not well maintained. So the corrosion actually started from the inner side of the hull and then penetrated outside. So because as you understand, the paint deterioration on the local pitting happens, corrosion happens because of the poor anode to cathode ratio. And similarly, another case is about the main vent of a ballast tank of INS Shalki. So where you can see that basically it's a stainless steel, and I would not go into the details, but then we can see that simple galvanic issues, weld decay happened because of joining of two dissimilar, even if it's stainless steel grade, but then we can understand what happens from the mechanisms and the metallurgical part of it. Similarly, another issue is the canned pump motor impeller. So impeller is rotating dynamic components, and we can see the erosion, corrosion, failure, and of course cavitation, erosion, and all those things. For example, it's a nickel, aluminum, bronze alloy. So we can see it's a dual alpha beta matrix microstructure, and how it the selective leaching and all those things. And sometimes the material chemistry, which is sometimes deviating from the specification, causes so much of problems, which probably difficult for the user to understand. Similarly, this was a board of inquiry case where these oxygen diving cylinders which the Indian Navy divers carry. So we can see a sailor on board with the diving cylinder. And what has happened in this, because of this actually blasted, this cylinder actually blasted, and one of the sailor had to lose his leg. So the basic issue was pitting corrosion, because you can see on the internal surface when we did this study, and the effective wall thickness reduced, and because of this pressure vessel design, the hoop stress concept, the thickness is the most important parameter. And even if it's small, even if it appears very small percentage in mm, but it's so much we can understand the hoop stress actually locally at the deepest corrosion pit surpass the yield strength of the steel. And another issue was the anchor shank, which is the anchor shank which is used to basically anchor the ships in near coastline. So in this case, what has happened was during operation and maintenance, the paint, it was repaired and it was repainted, but then already some crack was initiated, and it could not be at the right time it was able to detect. So because of this, actually caused a brittle failure of the shank. And once we did the material property analysis, we saw that even the steel over the time had lost its mechanical properties also. So coming on, so these were the simple case studies. Just wanted to highlight the basic corrosion forms we study in our coursework, and these simple things are causing so much of impact, detrimental impact on the naval assets. And we understand this that anodic protection, cathodic protection techniques as solution approaches, where the anodic protection is the anti-corrosive paints and anti-fouling paints and all those things. And in ship hull, there is another technique called impressed current cathodic protection, where current is also applied in together with the paint schemes to protect the ship hull. So these are a few anti-corrosive paints and developed by NMRL and the ICCP corrosion protection system. Now coming to the how, as we were discussing for the last 2 days, I suppose, and today I have seen so many, that the whole world is moving towards the data-driven solutions of applying data-driven solutions, including cutting-edge technologies for corrosion solution monitoring. So these are the important aspects as we are trying to, the corrosion mitigation industry is trying to go towards that direction. And IoT sensors, embedded systems, AI/ML enabled big data analytics, and then these are all data science and scientific computing framework and tools. Can these be applied for future structural health twin monitoring? The previous speaker explained with using combined FEM, or rather extrapolated the application of FEM by sensing technologies and dashboards and all those things. So, and in the with respect to the ship hull corrosion fatigue monitoring, basically it's a corrosion fatigue phenomena, because the sea waves are actually 0.1 hertz, and as previous speaker and sir mentioned, that low frequency is more detrimental in terms of corrosion. So these are the big data gaps. Sometimes where are the hotspots? Where are the sea waves load spectrum data? I mean, the ship is sailing, so it is really difficult to get the data. And of course, the corrosion monitoring data, it's such a large infrastructure. So this is we have been doing this corrosion-based life assessment for ship hull steels, where in our lab we generate this this corrosion fatigue fracture mechanics database, basically for those materials, including our metallurgical mechanical property database. and using fracture mechanics concepts. And in this we can see that this is actually a data of a ship where we have done the experiment, we have done the developed analytical methodology and the computational methodology also. So the entire thing has been kind of comprehensive developed, and end to end it has been modeled so that at least we generate the steel property database, because these are all imported steels as of now. Now the ships started making by India, but the ships which are like 20-30 years old, they are mostly from Russian origin. So this methodology, whatever we have done up to some level has been accepted by Navy, and it has been promulgated as a the naval policy document for conducting and for residual life estimation of Indian Navy ships. And on the right side you can see that the data which we are talking continuously is the importance of the right data, the accurate data, and the real-time field data. So Indian Navy actually provides, based on our feedback, that the real data is required. So they give the data in terms of basically sea state operation data, with sea state 1, 2, 3 and to 6. Like sea state 1, the moderate, very calm water, and sea state 6 is N+ is cyclonic conditions. So at least whatever data they maintain, kind of classified data, but then based on our input they give. So we incorporate in this history and try to calculate the the peak stresses, and then from the spectrum, Weibull-based spectrum modeling of this sea state, and then calculate include that in our algorithms and calculate the fatigue life based on the operational profile. And in the right side you can see what is the residual life if the ship has to operate in sea state 1, 2, 3. So based on that, some insight with respect to decision making they get, how much, if they want to extrapolate it, say for example to 8 years, then they have to operate, say for example, in close to sea state 3 and less. And this is the kind of MATLAB based software that we have developed. So I'll just briefly run through once. So basically it automates the entire calculation methodology, and that's why we are able to use it for all different, for example, 45 number of ships. And how we can use IoT systems, and many speakers have spoken in the past, and of course the world is moving towards those things. So we also trying to develop some prototype with simple embedded systems like Raspberry Pi and all those things, trying to. So we can see that these dashboards, how we can use for corrosion monitoring and any different environmental parameters, physics parameters, the steel, the material health parameters, and of course corrosion sensors. So there is gaps in terms of technology with respect to the corrosion sensing, but then that's what as this workshop is all about, to solve and identify and solve the problems in future. And energy management, as we understand, corrosion monitoring is also associated with energy management. So this just to show how computer vision and things can be used for energy management things. So coming to the last slide, just throwing up some insights. So many speakers have already spoken. So what are the different real-time sensing parameters we can capture: environmental, physical, metallurgical, and all those things. And there is a need to incorporate a hybrid data-driven and physics-driven based models, and where we have to see how fully automated systems can be developed by combining these latest technologies as well as our traditional and whatever the expertise knowledge we have. What we were discussing, it is important to translate this knowledge of our experts, of the corrosion scientists, with the first keynote speaker also mentioned. And therefore the need is to somehow translate this knowledge we have in our minds, the experts, the scientists, the professors, to somehow what we call it KPI, the knowledge programming interface. If we can using these AI, in the sense, if we can use large language models for these things, probably LLM model can study well curated by the experts, some 10, 20 PhD thesis or publications in for that particular application, can we digitize those things? And of course, last but not least, how quantum technology can, contribute. So yesterday I was just seeing one paper. So what can quantum computing technology bring an end to corrosion? So this was a question being asked, in this addressed, and how quantum computing technology can, be incorporated in corrosion management. That's all. Thank you.
Thank you, Vivek, for
Yeah.
the interesting talk on how practical problems are being solved by DRDO. Notwithstanding, everybody understands there is a tremendous amount of loss in the GDP due to corrosion, but still, if an academic or somebody wants money for research on corrosion, I think there's still a lot of questions. I think it's high time probably we should look at some national programs in this area. Maybe we have time for one quick question. I just had a question because recently we were involved in some submarine design. So when you talk about all these potential, I'm sure it is going to change from different sea because the salt concentration, the wave speed changes. So you're trying to collect some database in Indian Ocean, Pacific Ocean, and different locations now?
Yes, I mean, like oceanography department does.
They do.
They do that, but it is the need is to how when the submarine or the ship is operating in that location, how this real time correlation of, for example, the oceanographic data, and the Navy also uses this satellite based communication. So is there any possibility to connect them?
Connect
that
these
it
two.
makes sense to us.
Thank you so much, Vivek. Let us thank Vivek once again.